Okay, ladies and gentlemen, thank you for showing up and showing an interest in the second round of startup pitches at this year's Hydrogen Week here in Brussels. I'm Uwe Kerkmann, I'm CEO of H2UB. You have heard about H2UB. We are the ones organizing the big startup area, bringing 20 startups from Europe to this event and giving some of them the opportunity to pitch here on stage. Maybe you've listened to the first session and there was mentioning of first thing is give startups exposure, make visible what they are doing, give them a chance to explain what they are doing and hopefully find interested people and an interested audience in their technologies, in working with them, in supporting them and even investing in them. So what we are doing now is giving startups the chance to be visible here on stage. But before we start, a few words on H2UB. We are the European platform for hydrogen startups and the leading European platform for open innovation in hydrogen. So we cover the whole of Europe. We have more than 500 hydrogen startups in our network. We have a lot of very interesting companies and partners in our network that are very interested in supporting those startups, working with them and investing in with them. We are offering our own acceleration program, and yesterday on this stage you saw the pitches of the recent batch of our acceleration program H2UB Sprint, and today we have another selection of startups that would like to demonstrate and show what they are capable of. And for those of you who are not startups but interested in learning what startups in hydrogen are doing, probably interested in cooperating with them, just visit us at the startup area, talk to us, talk to the startups, and you will see there's an enormous potential of innovation in this great group of young and probably even not so young people who are starting their business in hydrogen, which is quite important. So without further ado, I would like to pass over to my colleague Moritz, who is in charge of our startup ecosystem at H2UB, and he will lead you through the presentation and the pitches of the startups. Thank you.
Thanks, Uwe. Thanks, Uwe, for the warm intro. Hi, everyone. My name is Moritz Glettenberg. I coordinate startup activities, and at H2UB, we are Europe's leading open innovation platform. I would like to see the slides here on stage, please. So we are Europe's leading open innovation platform for the whole hydrogen value chain. We invite corporates, we invite startups, we invite inventors and science to join the platform and push innovation, bringing down the cost of levelized hydrogen and bring innovation to the market to make net zero a reality. And Uwe mentioned it, therefore we have designed a program which is the H2UB Sprint, our flagship accelerator, where we accelerate highly promising startups. We select them carefully for technology maturity, for the potential to address the needs of our sponsors and partners, of course, and of course future potential looking at the hydrogen market. We address the whole hydrogen value chain from digital solutions, catalysts, new materials, to also green molecules, ammonia, you name it. The startups we accelerate, they are the scale-ups of tomorrow. You have heard from the CEO of DYNELECTRO a very impressive presentation and comments. Also on the capital stack, the startups we accelerate, they have already in aggregate collected 150 million in funding. So those are the scale-ups of tomorrow, and they are already scaling up. If you want to learn more about them and our ecosystem, the startups we accelerate, just talk to me or my colleagues. And I'm very happy to present you a selection of 6 startups from our booth. You find us at J30. You can't overlook it over there. Come to us and talk to them if you find it interesting. So the procedure will be as follows. You will see short pitches, 45 minutes, and after each pitch, you will have the opportunity to raise your hand and ask a question on their technology, on their team, on the strategy, whatever you feel. We can address it here, and of course, you're sincerely invited to follow up with them. The activities we do, they are supported by a strong network of industry partners, making it possible with their expertise, but also with their financial support to do the activities and deliver the activities and the excellence as we actually do it. So join the Hydroverse, join the ecosystem, and enjoy the pitches. First, the first startup will be a digital one. You know the discussion about the hen and egg problem along the hydrogen value chain, building the infrastructure, or where's the demand, where's the supply? You know all those conversations for years, and this startup is here to solve it with a digital tool. And they will show you how they do it and why they can do it. And I'm very pleased to introduce you to David Schwarz, who will do the pitch. Thanks.
Yeah, thanks. Thanks, Moritz, for the kind introduction. I'm David from H2 Digital, and we built the software as a service platform for the global marketplace of hydrogen. Some words of about the market. I'm sure you all know that the demand in green hydrogen is going to grow massively in the next years, but one situation which is a big challenge for that hydrogen market is a clear lack of transparency. Producers don't really know whom to sell hydrogen to, in what quantities, when, to what conditions, and so on. The other way around, industrial companies don't really know where to source hydrogen from, and there's not a liquid market yet for hydrogen where traders can get involved. That results in a situation that you see on the bottom right, that just a tiny part of hydrogen projects which have been announced are really reaching FID and are getting into operation. So what are we doing at H2 Digital to solve that? We build a digital backbone, a digital platform for all sorts of stakeholders to solve that intransparency challenge. So for TSOs and DSOs, for market and network development, for industry clients to position themselves as H2 sources or sinks, for traders, and so on and so on. But we're not doing that alone. We build on strong partnerships for public relations, for example, with a large German gas association, for planning of hydrogen production sites, to collaborate with consulting firms, for example. To integrate market mechanisms, we work together with the European Energy Exchange to make even more profound business decisions for market participants. And last but not least, we build digital ecosystems for hydrogen. And now coming to that example, maybe you heard of it a couple of weeks ago, the H2Med consortium launched a digital platform for their import corridor. A few words about H2Med. I'm sure you all heard of it. One of the large import corridors for Europe for green hydrogen. Their estimation is to deliver at least 10% of the European hydrogen demand by 2030. I think that's even a conservative assumption, what they're doing. So what did we do? We launched a platform where, first of all market participants along these 4 countries in H2Med can register. So producers, consumers, storage operators, traders of hydrogen register for free on there, put their data in there about their capacities, their timelines, and so on. They do matchmaking with the other participants. And then they submit calls for interest, which the TSOs, the 5 TSOs involved in H2Med, need to size their infrastructure and to have clear declarations of intentions, what capacities are needed at what pipelines. But that's just the start. We rolled out the platform this year successfully, built partnerships, built our company. But we want to roll that out even more in next year. First of all, geographically to involve other import corridors and other ecosystems, but also to advance technologically and build, for example, AI solutions together with Microsoft on that platform. Last but not least, our vision is to see H2 Digital as H2 Marketplace, which we want to develop together with partners to come from these first declarations of intentions to real bookings and matchings between producers and consumers. Just a few words about us. We're a software company, entirely software-based, but we have strong advisors, both in the software industry but also in the hydrogen market. And we're starting our first financing round, beginning of next year. First of all, looking for approximately 1 million to grow our team, but also to grow our position in that market and position ourselves even stronger as a digital platform. So if you're interested, come over to us, to our booth in the startup area, talk to us, or if you know someone who might be interested, reach out to us. Would be very happy to have a talk. Thank you.
So, well, ladies and gentlemen, that's the moment to raise your hands, ask a question to... Don't go off the
Sorry.
So, any questions on the technology, why can't you do what SAP or Microsoft can't do themselves? So, why can you do?
Well, I guess I would say we're quite early movers in that market. We're the first digital platform which wants to provide market development tools. And on the other side, we partner with these big companies. So we're a managed partner by Microsoft. And they trust in us and they believe in us that we can deliver a strong platform. That's why we see them more as a partner than a competition.
Oh, that's a strong partner, I think. So from the audience, please. Anyone? Last? Yep.
Hi. Interesting what you're building. Big question. Are you totally dependent on the information that you're receiving, or are you also gathering information which are freely available?
Well, if I give you the example about the H2UB platform, there we started from zero, and we take all the information that the market participants put in there. But we also worked in projects where we integrate the data that is already there, because most of these energy providers or network providers, they don't start at zero. They have their customer data available. They just want to have it in one place, want to have it aggregated, and then work actively with that. So that is usually how we go forward. You don't have to start from scratch. We can integrate all sorts of data which is relevant for market development for these players.
Thanks. A quick applause, please, for David and H2 Digital. Thanks a lot. So, and the clicker. So, the next pitches to come, they will focus much more on electrolysis and fuel cell technology. How to fix the bugs and the issues of the technology that we are all well aware of and that have the potential to drive down levelized cost of hydrogen. And one of them is DYNELECTRO. So we all know SOEC has a big promise, but also a big problem. And I think DYNELECTRO, they have probably a very promising approach to solve those issues. Samantha, please help us, yeah? And the stage is yours.
Thank you very much. My name's Samantha Phillips, and I am co-founder and CXO at DYNELECTRO. We are a Danish innovation firm, and the company name stands for Dynamic Electrolysis, so DYNELECTRO in Danish. And this is where we are addressing some of the intermittent nature of renewables. It is not a barrier in the way we operate our electrolysis systems. So DYNELECTRO, as I said, we're Danish. We founded in 2018 by a university professor, and I like to say I'm the longest employee. I've been there for 4 years now. So we are one of at least Denmark's success stories. We've raised 20 million euros to date in our 6 years that we've been around, and 50% of that funding comes from innovation funds, and we have some great venture capitalist partners. We have the Danish Import-Export Fund. We have Yara Industries, which are one of the large ammonia producers. And some of the soft funding innovation grants that we've received, we have money from Shell Game Changer and from the European Innovation Council. And that's actually one of the reasons why we get to be here today, is we've just recently received 2.5 million euros. And as part of that deal, we had a partnership with the European Investment Bank, and that helps us actually bridge our way with the technology. So a little bit technical now. The holy grail of hydrogen deployment is going to be efficiency at scale. And this is the space that DYNELECTRO operates in with our breakthrough technology, which allows us to leverage both scalability with efficiency. That's us there. So conventional electrolysis systems operate in what we call steady state direct current. So you basically have this very intense current coming into the system, which for high temperature electrolysis at the moment is leading to a high degradation. What we have at, what we do at DYNELECTRO is for every 30 milliseconds of electrolysis, we operate a reverse pulse for 3 milliseconds in fuel cell mode. And that reverse pulse allows us basically to stabilize the temperature differential across the fuel cell. I can go into much more detail, and I've got a really lovely microscope images that I can show you about the material science, but it's actually allows us to leverage the efficiency that you gain from solid oxide, but with the longevity that you see in the alkaline and PEM systems. And just to be clear, I'm not here to say you should do solid oxide and you shouldn't do alkaline or PEM. I'm here to say that all solutions are needed, and what you want is to operate each of the systems in their, say, strength areas. And solid oxide strength area is when you have surplus heat and you can do this heat integration. That's the last little bit technical bit. That's going to take us now to our applications. And this is one of my favorite colleagues you can see here is Mads, who is in one of our early prototypes that we have operating now in Denmark. Again, this was funded by regional funding and allowed us to actually get a lot of traction very early on with our venture capitalist investment. And at the moment we have, and I've just spoken to my engineers back in Denmark, 17,845 hours of continuous operation at our proof of concept scale. So that's more than 2 years operation where we've experienced less than 0.3% degradation per 1,000 hours. And anyone in the audience, I at least have one nod. That's where I see that degradation is unheard of within solid oxide electrolysis. That's where you're starting to get into the longevity of alkaline and PEM systems. So we are currently planning the deployment of our commercial scale operation in southern Denmark at a town called Mølle, and that is at the European Energy Facility. So we've just closed our seed funding round. Next year, so say September 2025, we will be doing our Series A funding, and that is me ready to answer some questions from the group. Thank you.
Thanks a lot, Samantha. So impressive numbers, impressive efficiency, but also impressive fundraising. Well, so same game, raise your hands if you have any question you want to ask to Samantha. So the gentleman with a tie.
Yes, thank you for the presentation. I was curious about the capacity that you're looking at. Is this like 10, 100 megawatts? What's the ideal for this technology?
Yeah, thank you. Right now we're planning a 1 megawatt commercial scale operation. And yeah, so once we've validated that technology, we will have that, say, unit operation and our repeat unit that we will be able to deploy at larger scales. So, and can you just tell me who you're from when you're asking? Just that helps me a little bit.
Hey, I'm Gnev Amir from Kaya Partners. We're a climate policy advisory. But my question is about the test that you mentioned, 17,000 hours. Are you able to share the current density that you operate at?
Yes, I am. Actually, if you come to the booth, I'll actually be able to show you the actual field data. We operate at thermoneutral potential, so I think, but I can show you, I can do a deep dive of that data at my booth. We're at the hub bit, the big startup area just out back there.
Yeah, so we have some more time, please, yeah, over there. Yeah.
Thank you very much. I'm Hussein from Imperial College London. Just wondering, did you also consider the reversible solid oxide electrolyzer as a potential future technology?
Sorry, can you say that again?
Did you also consider reversible solid oxide electrolyzer as
Yep, that's a great question. And actually, that is a space, the current technology area that we're at right now is we're actually doing reversible operations. So you can see how we do that brief dip into fuel cell. So the current application that we're industrial application, we're looking at a 4 megawatt deployment where we add reversibility in as a permanent feature on the power electronic side, and we're doing that in a biogas installation, so you can either boost your methane production or you can actually go into energy production, electricity production. So thanks, that's a great question.
Thanks. If you have further great questions, don't hesitate to approach Samantha after the pitching session at our booth, J30. Thanks, Samantha, for an awesome pitch. And I think it's ready for the next one. So
thanks very much. Oh, thanks very much for the opportunity to actually be here. It's actually really a great venue with a lot of opportunities. Thanks very much. Okay.
Thanks. And the clicker. Just put it. Yeah. So from SOEC, we go to PEM because not only SOEC has durability and efficiency problems, so does PEM. We all know that durability is a high issue, but also this is connected with a drop in efficiency over time. And the next company, Hydrogenea, will tell you how they're going to fix it with a novel process and material. Thanks, Pitt. Come up, and the stage is yours for your pitch.
Thank you for the introduction. Hi. I'm Pitt, CEO and co-founder of Hydrogenea. And of course, with my name, I'm the person pitching for Hydrogenea today. So at Hydrogenea, we are on a mission to make green hydrogen competitive. And we want to have a future which is totally emission-free. And the question is, why don't we do it today yet? We faced several challenges. On the one hand, the costs of the components are too high, the efficiency is too low, and also the durability is a huge issue. Let's zoom into this a little bit. On the right side of the slide, you see a typical scenario for green hydrogen production, which means we have a wind turbine connected to a PEM electrolyzer. And when it comes to lifetime, we see that a wind turbine lasts for 30 years, but a PEM electrolyzer only lasts for 10 years. And this gap needs to be filled with innovation. And all of these obstacles I just mentioned add to a high levelized cost of hydrogen. And that's the real bottleneck here. So we have to get down the costs. To understand how to overcome these obstacles, we had a look into the supply chain. And we figured out that the core component of the entire green hydrogen economy is the so-called membrane electrode assembly. And regarding this supply chain, you can just imagine a computer and its chip. Everybody knows when a chip of a computer performs properly, the computer runs perfectly fine. In case the chip breaks, the computer does not work at all. And it's the same here. And if we translate this into the real world, into some numbers, we see here a scenario of a PEM electrolyzer, which is engineered to last for 20 years and costs around 3 million euros. And the limiting factor is the membrane electrode assembly, because this only lasts for 10 years, but adds up to 25% of the entire system costs. So this is really a thing we need to focus on, and we are not allowed to mess up anything here. Now, what do we need? At Hydrogenea, we have the following two innovations. On the one hand, we are focusing on the nanomaterial, which means we have a catalyst support and the catalyst designed really on a small scale, on a nanoscale. And then with the process, with our coating process, we have the second innovation. And these two innovations combined in a continuously running roll-to-roll process, which can be easily upscaled, summarizes our innovation. And the USPs of our technologies, on the one hand, an up to 10 times higher lifetime, and up to 20% higher efficiency, and also focusing on the novel and scalable production process is what we got patented. This means for our customers on the electrolyzer side, but also on the fuel cell side, that on the one hand, the investment costs go down, but also the operation costs go down. So the total cost of ownership are lower. And in this way, we are able to reduce the levelized cost of hydrogen, and only in this way, it's possible to make green hydrogen competitive. Where are we at today? We are focused and localized in the western part of Germany, which is Gelsenkirchen. We started the company within this year, already got our first paying customers, and with the grants we already got, we were able to build up the core team and assemble, you can see over there, our production line, get the production line running. And now we are focusing with our pilot customers a serious production. And also what we do, we are preparing our seed finance round for the second quarter of next year. So today, my colleague Marlene and I, we are here at the startup booth of the H2UB J30 to speak with you about how we can make green hydrogen affordable and competitive. Thank you.
Thanks, Pitt, for your pitch. Ladies and gentlemen, so the lady in the last row.
Hi, and thank you for the presentation. I'm Ilaria Schiavi from Environment Park, and I'm the coordinator of a project that looked into the recycling of MEAs and the recovery of precious materials. So you're looking into a new material now. Have you considered recyclability or any of the sustainability of your materials? Thank you.
Yeah, thanks for the question. This is always a very big topic to not just speak about linear economy, but a circular economy. So what we can do, actually, I did not go too much into technical detail, but what we can do is we can coat the catalyst layer onto the electrode, and we don't implement it into the membrane, which helps us quite a lot with the recycling in the end. Because what you do usually, you have a catalyst-coated membrane, and the polymer sticks to the catalyst, and what you have to do, you have to burn it in the end, right? And what we can do is we can separate it properly. So we have now applied for a project to really analyze it, how much we can really separate the electrode from the membrane after a couple of hundred hours of operation, or maybe the catalyst sticks to the membrane. This is what we still need to analyze. But with our approach, this is possible, right? To have really like the separation of the membrane and the catalyst, which is typically, from the state-of-the-art point of view, a big issue. So in this way, we can easily put the metal again into the cycling loop. And yeah, we have to take care about this. I'm not saying that we have the solution yet, but we are working on it.
Further questions? Please go forward. Look. So we've talked about circular aspects, recyclability. Probably a question from me on strategy, go-to-market. So what's your plan in scaling up production and also the customers you're targeting? I mean, if I read the newspapers, cars is not a very promising market for fuel cell applications anymore. So can you elaborate on your go-to-market strategy and the fuel cell market?
Absolutely, yeah. You're right. In the fuel cell, we have facing some challenges because we were focusing on not the right way. Like with the car, we cannot compete that much with the battery in this scenario. But it makes more sense to focus on the heavy-duty transportation, like with trucks or ships and trains, and that's really the way to go. But a huge issue there is lifetime again. Like a car is operated for 8,000 hours with a couple of on-off cycles. And this is what we can do with the technology from today's perspective. But when we go to a heavy-duty transportation, we need easily 25,000, 40,000 hours of operation. And there, the durability is really the bottleneck. And with our technology, with our nano catalyst support, we don't face any degradation, which is an issue. So with our customers, with our clients together, we can solve this problem. And that would be the strategy for fuel cells. but I think this is still on a development, right? So it's good for us to focus on both markets, fuel cell and electrolyzers, to get some traction there as well.
Thanks a lot, Pitt. So, but talking about fuel cells, this is a very good topic also for the next pitch. Thanks again. A warm applause for Hydrogenea. But talking about fuel cell applications in HGVs and maritime and other niche applications of mobility where fuel cells have a competitive edge against batteries, I think there is no one better around to talk about this than Jonathan Brown from Hypermotive. Pleasure to have you, and the stage is yours.
Thank you. Hello, I'm Jonathan, Strategy Director at Hypermotive. Ships, trains, trucks, other heavy industrial equipment are the hardest to reach parts of mobility and logistics for zero emissions. I was flying home from a conference the other week. I've been chairing a panel on the challenges of mobility, and out of the plane window, I see the view behind me. From 37,000 feet, the plume of emissions from that large container ship are clearly visible to my eye. Why am I showing you this? Well, our vision is a world where ships like this run on clean, green hydrogen, emitting nothing but clean air and water. Shipping is currently the cornerstone of global trade and commerce. Today, more than 99% of ships run on oil and gas. Ship owners and operators would like to be more sustainable, but it's simply not feasible in many cases. A single large container ship like this might hold up to 10 million litres of fuel at one time. 10 million litres. That's around 35,000 tonnes of CO2 per tank full. It's a big problem. So why don't they transition to clean green hydrogen? Well, it's difficult. It takes a lot of time, it takes a lot of money, and it's very complex. It also requires expertise far beyond the realms of most shipbuilders and other industrial equipment manufacturers. So that's where we come in. At Hypermotive, our mission is to accelerate the adoption of zero emissions technologies. Putting fuel cells into ships and trucks and trains is not new. What is new, though, is our System X technologies. We are automating the process of integration. We have digitalized our experts to supercharge the process of putting fuel cells into things like ships to make it fast and easy. But that's not all. To showcase the power of the technologies, we have collaborated with one of the giants of industry. Together, we are creating a marine fuel cell power system. The partner for this with us is Honda. Our leadership team have over 120 years of experience delivering into the power and mobility sectors. We've been putting fuel cells into ships and trains and trucks for almost a decade at Hypermotive. We know how difficult it is to do well, and we know how to do it properly. The burden of that complexity lies with us. But that's just the start of it. Within 4 years, our technologies are going to be supporting the hydrogen value chain from end to end. We're working with Luxfer at the moment to create smart, digitalized hydrogen logistics systems that will enable the value chain to create hydrogen and transport it to our customers at the other end who will be using our products with Honda. Standing on the shoulders of these giants will bring their customer base to us and allow us to realize a market for hydrogen worth more than $500 billion by 2030. So, we have the experts, we have the customers, we have the secret source of the technologies. What we're looking for today is some funding to help us get from pilot to production with our new ventures. The planet and the human race don't have time to wait. We'd love you guys to be part of the journey with us. like the others here, come see us over in the startup area on J30 if you'd like to talk any more. Thank you.
Thanks a lot. Before we start the conversation at the startup area, once again, questions from the audience to raise now how those guys actually do what they do. So.
Yes, thank you. So, Bo Broom from the New Energy Coalition from the Netherlands. I had a question when it came to the fuel cell, because you also talked about integrating into the trucks and stuff. Do you have actually also some examples from pilots that you ran in the past? Or is it possible to do it, for example, in a tractor? To put it bluntly, I'm currently also looking for a fuel cell to integrate it into a hydrogen tractor. It's not on the market at the moment. Is that a possibility?
Absolutely. So we have worked with the majority of the world's, I guess, leading fuel cell manufacturers, from PowerCell to Hyundai to Honda. And we've worked at integrating their fuel cells into a range of different applications. So absolutely, agriculture is one of those target markets where hydrogen is going to become a thing. And there will be a fuel cell system out there that will work for you. It may need some modification to get it into the tractor. And again, we can help with that journey. So where we work is we will work anything from just a stack and building a balancer plant around it to then taking a full automotive style system with everything already in place, like the guys in Toyota or Hyundai or Honda, and putting that into a new application where it will be configured to work in that particular kind of application. So absolutely, when it comes to a tractor, that certainly is one of those key markets that we will see fuel cells in the future.
Thanks. So we got one more question, but I would ask you to keep it short and the answer also straightforward.
Sure. Yes, hi, Willem Stevens again. Can you tell me a little bit more about your organization and the capital that you need, and why do you need that?
So the organization was created by a team of ex-fuel cell engineers from Intelligent Energy, but they also had a lot of experience and background working with large global OEMs in the automotive sphere, large consumer electronic manufacturers, aerospace companies, and so on. We need the capital because to demonstrate a product is simply step 1 of step 10 to get a commercialized, reliable, and robust product to market. We've all developed cars and trucks and trains in our lifetimes at the company, and we know that that process is a long and expensive process to go through all the certifications, go through all the testing and all the validation required so that you can put a fuel cell into a ship and it will do the job. Because what we can't afford to do is put undeveloped products into applications like marine where they will fail, and then it causes a slowdown in the whole adoption of the hydrogen technology.
The answer was a little bit longer than expected, but nevertheless, it was, I think, a good answer to the question. You can continue the conversation at the booth. Thanks a lot, Jonathan, for your pitch.
Thank you. Thanks all.
So, we're getting closer to the end. The next pitch, so we stay in the realms of fuel cells for a minute. We talked about membrane electrode assemblies, how the whole system is engineered and driven, and the next company doing the pitch will tell you more about coating processes and how to fix the inefficiencies and durability issues in bipolar plates in particular. Ravis from Matteco, welcome to the stage.
Thank you, Moritz. Good afternoon, everyone. A fossil-free economy, this is something that we all are looking forward to, and the green hydrogen is that key element that can help us to bring this closer to that achievement. Nevertheless, there are 2 significant problems to realize this vision, and both are inside electrolyzers that strip green hydrogen from water. First, corrosion. Hydrogen creates aggressive environments, so electrolyzers quickly become unreliable and require high maintenance cost. Second, high cost of catalytic materials like iridium and platinum that are used for the green hydrogen production. Moreover, these materials are rare earth and have limited availability. And this is the bottleneck of the industry today. We have 2 options. We have 2 options here. We can launch space missions to Earth, to asteroids and other planets and look for iridium and platinum there, or we can look closer to our homes in new materials. And this is exactly what we do. We, in our R&D center, we create new materials in a form of nanocoatings. We also have developed very powerful nanocoating process, and that helps to support our clients in 2 steps. First, we develop nanocoatings. We can use almost any material from the periodic table, including the mix of these materials. And second, we nanocoat components, significantly reducing increasing the protection against corrosion, as well as reducing the cost. Current coating technologies, they are in the quality versus productivity trap. High-speed magnetron sputtering, or HMS as we call what we owe, is merging the high quality of coating what the PVD and ALD could offer with the cost efficiency and scalability of mass production methods like electroplating. Also, conventional coating technologies, they use high temperature and hazardous chemicals that lead to high energy consumption and pollution. HMS, it is employs physical process instead of chemical reaction, reduces the energy usage, as well as we don't have any hazardous waste at the end of the process. Last year, we have launched already the first mass production continuous inline that is already capable of supporting our clients at mass scale and right now. 2 years from now, we plan to launch a bigger mass production line which will be capable of serving the industry with over 10 million coated components per year. Currently, we offer this as the service-based. So we receive uncoated components, coated in our inlines, and then send them back to our clients to be assembled in the electrolyzer and fuel cell stacks. But we're also considering other business models currently with the client. Geographic location, our scale-up is planned currently for Europe, where most of our clients are based, but other geographic locations, North America and Asia, is also part of the discussion. If you are an electrolyzer or fuel cell manufacturer, we would love to talk to you and to see how our solutions could help you achieve your technological and business goals. If you are a components manufacturer, let's have a discussion on how we can merge these technologies to create a ready product that can be offered to our clients. Thank you, and I would love to talk to you further. Please visit our booth at J30 and have a discussion. Thank you.
Thank you. Thanks. Well, ladies and gentlemen, anyone with questions concerning coating processes, efficiency, or something like strategy? Anything? So, probably.
Everything is clear.
Everything seems to be crystal clear. So, just once again, probably the question, why can you do what the other manufacturers can? So, I mean, the German industry, they are well known for producing high quantity and a high quality. That's their competitive edge. Why can you outcompete them?
That's a good question. It is basically through our tests with the industry that we get this assurance from. So, as early as possible, we try to test our coatings with our clients, fuel cell and electrolyzer manufacturers. And the feedback that we get, for instance, recently the tests with one of the leading fuel cell manufacturers revealed that we are on the top of the list in comparison tests that were 8 other competitors competing coatings were tested. We ended up #1. So that gives us the confidence that we have a technology that could really bring the difference to the market.
Thanks a lot. Ravis. So follow up with them during lunchtime, and I'm happy to present you the last pitch of this session. So from the new technologies, SOEC and PEM, we go back to Alkaline, which has been around for 100 years, but there are still teams out there trying to revolutionize this old technology, which is well established with all the players, you know them, like ThyssenKrupp, but Teresa from WEW will tell you in her pitch how they revolutionized this old technology.
Thank you. Yeah, hi everyone. I'm Teresa from WEW, and as Moritz already said, we are producing and developing alkaline water electrolysis stacks. One stack has a capacity of 0.5 megawatt, but you may ask, what is now the special feature about this stack and this technology? To answer this, I will start with some numbers. And you can see here the electrolyzer manufacturers within the last 4 years. So at first we can see on the left bottom side the overall number, which is increasing significantly. But also we can see a shift of the majority from the west to the east. And this shows at first that we are quite close to a market saturation, and secondly that the price pressure is increasing. So let's have a look on the cost development of the hydrogen capex especially. The example I've brought here was published last year by the Hydrogen Council, and it's an example from the US and especially a 1 gigawatt system. And looking on the costs of 2023, we can see that they are much higher than expected before. But the good news is now that we can, even if we take under account these updated estimations, we can expect the prices and the cost especially to fall within the next 2 years. Looking on the electrolyzer, which is the blue part of the scale, the cost could fall about 35 to 45% until 2050, which means that we are getting below $200 per kilowatt. So if we compare these now, the US numbers, to European and Chinese prices, I focus now on the stack because this is one of the major components of the electrolyzer, and these numbers were published by Bloomberg this year, and following them, the Chinese stack prices are already at about $100 per kilowatt. And if we assume we will import the Chinese stack to the EU, there have to be an add-on for logistics, for requirements we only have in the EU. So let's say it's about 50% on top. We still have this huge difference to the European stack prices, about 50%. So even if we assume now maybe the yield is a little bit overestimated, or maybe the performance is a little bit less, it's still quite obvious that we need to reduce the cost of the electrolyzer drastically. And exactly that is the special feature about the WEW stack. So we don't focus on the performance, we focus on the capex reduction. And how do we do that? We have different approaches. At first, we have a cost-to-design approach, which means that we avoid really cost-efficient materials and we reduce the material input overall. Secondly, we did the design to manufacturing, which means we have a highly automated manufacturing, and also, it's designed to directly high volumes. Thirdly, also the design is made for logistics, which means the footprint is fits very good to a container, and therefore the shipment cost sink overall. Then we follow a plug-and-play approach. That means that the manpower in the end is reduced on the on-site integration. And furthermore, we also enable the system costs to be reduced by a really high robustness. So our vision is that in the future, our WEW stacks will then be provided all over the world, which we call in German, vom Pott in die Welt. So with these words, thanks for your attention, and talk to me at the booth after the pitch.
Thanks a lot, Teresa. So I believe that we all smell the burgers from the food truck, I know, but we still have the opportunity to ask 2 questions, or 3 probably, on WEW technology, their strategy, whatever comes to your mind. Yeah? The gentleman in the first row? Yeah.
Hi, Willem Stevens again from Clear. Great. What you're building, what are you looking for and how much are you looking for? What are you going to do with the money?
So our next step is to have the first demo in the final size. So that will be the next milestone from our side. And then depending also to the market pull, we will scale up our production side to start this providing all over the world. But we will start in Germany. Is it answered your question? Okay, thanks.
Anyone? So, one last question from me. What keeps you technology-wise awake at night when you try revolutionizing, bringing down material costs, reducing the thickness of materials? What issues do you face and how did you overcome them?
One of the issues we face is that the joining technology is a new one. So it's maybe not that obvious, but this is if we reduce the material so much, we have to test there a lot to have the robustness in the end. And how do we do that? We are a quite small team in Dortmund, but we have a huge network with universities and partners, and so therewith we can increase our capacity and have different test fields and lots of students working together with us, which just make the process more rapidly in the end.
Thanks, Teresa. And I know the rest of the team, a wonderful team of seasoned professionals from world-leading manufacturers who actually know to get stuff done. Thanks a lot for your presentation. Thanks also to the others. One last call, join the Hydroverse, join the conversation with the startups, but also with us. You all are invited to participate in our open innovation platform and push innovation to the market from prototype to industrial scale. And I want to ask everyone who has been pitching here, Samantha, Pitt, everyone, just come on stage for a last photo. Thanks a lot for your attention. Enjoy your lunch and see you at the exhibition. Thanks. Oh, sorry, I forgot something. Uwe.
Yeah. We have one last remark. If you like the situation, seeing startups on the stage, today it was 6, we have 14 more in the startup area. And what I'd like to do is to invite you to our own Hydroverse convention next year in June in Germany. And I'd love to see the slide also. So can we have a slide? Yes? Yes, we can. So you have the QR code. It's in Essen in Western Germany, and it's a convention especially designed to the needs of startups. So you will find more than 50 startups from all over Europe. You will find a lot of interesting and interested corporations and companies, not only from Europe, but from Asia, from the Americas, and so on. And what is very special about our convention is you will also find a lot of very interesting investors. So it's all about innovation, it's all about startups, it's a very dedicated session that is not a general hydrogen conference as you find it anywhere. And since we are teaming up with Hydrogen Europe, this is kind of the summer edition of the innovation part of the Hydrogen Week here. So if you're interested, we shall be very happy to see you next year in June in Germany. Thanks.